Um, anyway, it's Ernie Noah's Workshop series, and wanted to show everybody what I did to do this boring on this horizontal engine. One of the biggest challenges I had was figuring out how I was going to mount this somewhere on a machine to make this circular pattern, not having a milling head or a boring head of that size. Also, trying to put this onto the milling machine presented a challenge, since there was only just so much clearance on my milling machine, and it needed a little bit more. So the idea was to set it up on the mill table on the lathe, and that's what I've done here. This is a milling table that can raise it up and down. I can make it go back and forth. The trick was trying to get this adjustment this way. Getting it this way was pretty easy because I could take off of here, but getting this took quite a bit of time to get it just right on this cross table, slide table. I wanted to make sure I touched all the points here, so I wrote some things down. Then what I did was make a boring head jig that I was able to mount the cutter in, and I'll show you that in just a minute. This is nothing more than a big 2-inch piece of aluminum with some holes bored in it for the cutters to go in, with some set screws on it, and a slightly better version of this coming up. So this is basically the setup I used. This boring bar, made by hand, it's just a round piece of aluminum, 2 inches in diameter, with a hole drilled in it to mount the boring cutter. A boring cutter is kept in place with these set screws right here. There's 3 set screws to hold it in place. Adjustment can be made, since it's using a 4-jaw chuck, using this gauge, and adjusting this to whatever diameter you're looking to bore, within the range that it's capable of, by adjusting the 2 opposite set screws. Keeping these 2 set screws in the evening, or these 2 jaws in the even setting. But you can see let's see if you can see the gauge. Now you can't see the gauge now. I'm going to zoom in on that a little bit. So 1 jaw is reading. I'll turn this around a little bit so you can see it. If we set that at 0, you can see that it's about 0.010 of an inch offset. So by adjusting it with this gauge, you can get a very accurate measurement once you figure out where you are. This was also used as a jig to turn the crank by inserting it in a borer hole through here, and there's 2 set screws here and here, locking it in place so that this inside crank area could be turned. Anyway, I figured I would use this chunk of aluminum for at least that process. So Okay, this piece is done. Well, at least this part of it's done. The next thing that has to happen is these, let's say 6 holes have to be drilled in here. They have to be located, but this will be used as a template to drill those holes and tap them. And this will hold everything together temporarily while I drill all of the holes. And I think at this point I'm pretty much so done with this piece, other than drilling some holes for a bushing here, and of course this piece on the back end. Yeah, this piece on the back end will need to be machined. These caps will be inserted and bolted on, and have little oil holes in them. They go on the upside. They would go right there. And of course the axle, the crankshaft. It's not quite the way it goes, but this gives you an idea of where all the pieces will go in there once it's in there the right way. Because you can't get it in there now, but that will be, let's see, let me pan back a little bit. Yeah, this crank will go in here like that. And basically this will be kept on with those keepers. And this goes right in here. Looks like there's going to need to be some modifications here. It doesn't look like it'll fit, but this will be the next challenge, is setting that piece up. Of course the cylinder mounts on this way somewhere, probably like that, through this plate. And this will all be together like that.